Okay, so in this lesson, we are going to take a look at the correlation coefficients, especially the Pearson correlation coefficient. So before we get on to that, let's just jog our memory a little bit about scatter plots. So we have done scatter plots, and we have seen some examples of scatter plots, and we know that we use scatter plots or scattergrams for comparing the association between two numerical variables, right? So it's actually a graphical display, and we call these two variables covariables also, and each point on the scatter plot represents a pair of scores. What I mean by a pair of scores is, now if you take the point that is just above age 8, there is a point there which, if you draw a horizontal line all the way to the y-axis, it will give you an age for it, probably a weight for that, probably 19 kilos or 18 kilos. And if you draw a line parallel to the y-axis, a vertical line right down to the x-axis, you will find that there is a age component in it, which is 8. So each point on the scatter plot has two values. So it's a pair of scores. And if these variables, these two variables are correlated, if age and weight are correlated, the points will fall along a line. We call it a regression line. And the better the correlation, the tighter the points will hug this line. Now, the correlation coefficient is actually a numerical index or a representation which summarizes some of the main features of a scattergram. So the most common correlation coefficient is the Pearson correlation. There's also a Spearman's rho, but we are not going to discuss that in our lesson or in this module um, for this particular course. We are not going to be looking into that. Pearson correlation gives us two pieces of information. One is the closeness of the fit of the points of a scattergram to the best fitting straight line through those points. And then it gives us information about whether the slope of the scattergram or scatter plot is positive or negative, right? And the Pearson correlation does not replace a scattergram. Without a scatter plot or a scattergram, you won't see any outliers, for example. Now, if you will only see the outlier when you see the scatter plot, and if you see some very extreme score, that particular one score can actually influence where the regression line is. So only when you see the point on the scatter plot, you will be able to remove it, or decide on your to have the scatter plot drawn again for the interquartile range, if that's what you wish to do. So what we need to know is the Pearson correlation doesn't replace the scattergram, right? A correlation shows also an association between two variables. It does not show a cause. So here we have two variables in our example, age and weight. It's not that one variable causes the other to increase or decrease. Here we have a positive correlation. Age is not the cause of weight. It could be the cause of weight at this young, age group, 1 to 12 or 1 to 14. But as we get older, age is definitely not a cause for weight gain. Neither is weight the cause for the increase in age. So we have to know, as counselors, when we have these papers and they tell us that there is a very strong positive correlation between two variables, we need to understand that it does not mean that one variable is the cause of the other, right? So it's a very, very important factor to know, because some time ago, there was a study done between children who were displaying some violent tendencies, more bullying in school, and the number of hours they would spend watching very violent TV shows, things like that. So playing violent video games, and there was a very strong positive correlation. But unfortunately, it was a strong correlation, but it didn't say it was one was the cause of the other. The scientists of that time, the researchers, did not say that violent video games or watching violent TV shows was causing the children to become bullies and more violent in school. No, what they simply said was there is a very strong association between these two variables. So it could be that a child could be genetically disposed to being more to have more violent tendencies than other children, and those children would prefer to watch violent TV programs or play more violent video games. You cannot say that it is the video game that caused violent behavior in school. So it's really important, because once it came into the media, the general public, what the message they received is that watching violent TV shows causes children to become violent. So there is no such research done. So that is why we as counselors, when we read these research papers and try to understand what it says, we have to know that a correlational study, it gives us the strength of the association between two variables, and it does not tell us the cause, whether one variable causes the other variable to increase or decrease. Now, the plus or minus sign tells us something important about the slope of the regression line. The regression line is the best fitting straight line through the points on the scattergram. A positive value means that the slope is from the bottom left to the top right of the scattergram. On the other hand, if the sign is negative, then the slope on the straight line goes from the upper left to lower right on the scattergram. Now, the value of the correlations are from 1 to 0 if there is a positive correlation, or -1 to 0 for a negative correlation. So we have to know the larger the numerical value, then the closer the relationship or the association between the two variables. So a value of 0 means that the points on the scattergram are randomly scattered around the straight line, and therefore it should indicate that there is no straight line relationship between these two variables, and that means the association is very weak. Now, if you'd like to have these verbal labels for different sizes of the Pearson correlation coefficient, then this is the commonly described scheme. A small correlation is 0.10 or larger. A medium correlation is 0.30 or larger. A large correlation is 0.50 or larger. So let's quickly go through a short summary. The components of the correlation coefficient are the signs plus or minus, which shows us the direction of the slope of the regression line, and there is a numerical value which indicates how much variation there is around the best fitting straight line through the points. The higher the numerical value, the closer the fit. Now, let's find out what is this, what we mean by covariance, right? Before we look at covariance, let's remind ourselves how we calculated the variance. Now, see, the equation given here is where x would be the scores on a variable, x bar would be the mean score on that particular variable, n would be the number of scores, right? And sigma is actually the sum that follows, right? Now, we can also expand the same formula and re-express it like this. You can see this is the same equation for variance. It is simply expanded to show the square of x minus x bar as a multiplication. So we have gotten rid of the square sign. Now the formula for covariance is almost exactly the same as this formula for variance, but instead of multiplying scores by themselves, we multiply the score on one variable x by the score on the second variable y, having first subtracted the relevant mean. And we have to understand what n here means. N is the pair of scores, the number of pairs of scores, because when you are looking at two variables, you have a pair. You saw in the scattergram that each point on the scattergram has two scores in it. So there is a pair of scores. So n here in covariance would be the number of pairs of scores. Right, and so we also know that we would get a large positive value of covariance if there's a strong positive relationship between two variables, and a very big negative value if there is a very strong negative relationship between these variables. And if there is no relationship between the variables, then the covariance is closer to 0. Notice that unlike variance, the covariance can take positive or negative values. Now, covariance is a measure of how much scores on one variable increase with scores on the other variable. Now, the Pearson correlation coefficient is simply the covariance divided by the maximum that the covariance could possibly be. Now, to calculate that, we have the equation goes like this. To calculate the Pearson correlation coefficient, I know it looks very complex, but we have a very clear explanation from the textbook, so please take a read and take a look at it, and we will go through that in the class in the next lesson. And you have this, I think I've made a mistake on the page number. I believe the page number is 107 or 108. So have a read through this, and we will discuss this equation along with table 8.1, and we will do that example given in the textbook so that you understand how to calculate the Pearson correlation coefficient.